Hey, what's happening, guys? Well, it's been a little while since my last tutorial, quite a while actually, and I've been pretty busy with my day job, but I'm back with a fun one today. We're going to look at how to use the GPIO connectors to light up some LEDs and make kind of an LED stoplight. So if that sounds kind of cool to you, stick around and I will show you how. Alright, so this is going to be a little bit more of an advanced tutorial. I'll try my best to explain it so that even a beginner could do it. You're going to need to acquire some hardware first before you can actually follow along. But, feel free to watch the full tutorial first to see if this is something you might want to try. And then you can always come back and watch again later when you have all of the hardware you need. Most of these parts you can usually find at your local Radio Shack or online at Adafruit or whatever electronics store you happen to be close to. I'll provide some links in the description below. The total cost for all of these accessories that you will need should be around $30, give or take. And first off, you're going to need a breadboard. And we're going to use the breadboard to hold all of the wires, LEDs, and resistors for our project. And you can either use a half-size or a full-size breadboard. I would recommend a full-size. It just gives you a little more flexibility for future projects, and they're really not that expensive. They're around $6. Let's take a look along the edge of the breadboard. You'll notice a plus column in red and a minus column in blue. And depending on the board, these two columns may be reversed, so just keep that in mind when you start doing your wiring. We're also going to need a Gpio Cobbler from Adafruit. The Gpio is the Raspberry Pi's general purpose input and output connector. And the cobbler that I'm going to be using is not 100% necessary, but it basically provides a way to get the Gpio pin connectors extended away from the Raspberry Pi and onto the breadboard more easily. You could wire the pins directly to the breadboard without it, but the cobbler just makes it easier. Next, you will need some wires to connect our circuits. I bought a little multi-pack with varying lengths and colors. You should be able to find something similar to this, but it doesn't have to be exact. We also need some resistors, and I have here some 4-band 270 ohm resistors, but honestly, for these LEDs that I have, anything above 100 ohms should be fine. The higher the resistance, the dimmer your LED will be, but it's better to have too much resistance than to have too little. And if I did my math correctly, my LED should work with anything above 65 ohms, but any resistance below that, the LED could actually burn out. So we don't want that to happen. And let's take a moment to talk about the math that I just mentioned. To calculate the level of resistance that you'll need for an LED, you'll need to apply Ohm's law, which is E equals I times R, or easier to say, voltage equals amperage times resistance. And don't worry if this sounds confusing, it's not as hard as it sounds. If you can do simple multiplication and division, you can figure this out. An easy way to work this out is with this little circle diagram, just like this, E over I times R. So let's figure out what resistance I'm going to need for the LEDs that I picked up. Using this circle diagram, we can figure out what we need by covering up which value we need to find. For instance, if you need to find the resistance, cover this up right here, and you'll see that we need to divide the voltage by the amps. And if we want to find the current, we cover up I, or amps, and divide E by R. And to find the voltage, we just multiply I times R. And if you look on the LED packaging here, these LEDs are rated at 2 VF at 20 milliamps. And since we know our LED has a forward voltage of 2 VF, so that's forward voltage, we need to subtract the voltage that the Pi's GPIO pin is supplying by the LED's voltage drop. We're going to be using the Pi's 3.3 volt rail, So let's subtract our 2 volts and we get 1.3 volts. And now we need to divide that 1.3 volts by our amps, which in this case is 20 milliamps. And we're going to need to convert that into amps. So let's move the decimal point here and we get 0.02
because 20 milliamps would be 2/1000ths of an amp.
So 1.3 divided by 0.02 is 65. So we need 65 ohms minimum for the resistance to make sure that we don't burn out our LED. And you'll also usually notice on packs of resistors that there is a percentage listed. And this is the variance. The 270 ohm resistors that I'm using have a variance of 2%. So it could be providing resistance between around 264 to 275-ish ohms. You know, it's usually a small variance there. So let's see. The other rail on the Pi provides 5 volts. So if we were going to use that side, let's just see how much resistance we would need. So 5 volts minus that 2 volts for the LED, and then divided by 0.02 for our amps, will give us 150 ohms. So even if we wanted to use the other side of the cobbler, the 270 ohm resistor is still more than enough. All right, so now let's move on to our LEDs. You can try out this project with just one LED if you want, but I'm also going to show you how to make sort of a stoplight configuration with red, yellow, and green LEDs. And we'll even try a little timer script that can turn the lights on and off just like a real stoplight does. So when you're shopping around, look for some 5mm, 2 volt at 20 milliamp LEDs. Just get one red, one yellow, and one green if you want to do the full stoplight. Otherwise, you can start with just one of whatever color you want. Now, once you have all the parts we're going to need, let's start assembling our circuit on the breadboard. And I'll have links to photos of the circuit layout for a single LED and for multiple LEDs in the description below, as well as the GPIO pin layout, so you can get familiar with that. The first thing we'll do is plug the cobbler into our breadboard, and it can be a little tough to get into the breadboard holes, but just gently kind of wiggle it back and forth and give it some pressure and slightly work it into the breadboard. Line it up just like this, the way that I did, so that our numbers will match up. Put the outer row on one of the inner tracks before the gap like this. I've plugged the cobbler in 2 rows down, with the pins starting on row 3. So you should see Pi Cobbler on the top close to the first row. Now we can plug the cable into the Pi and into the cobbler. The white stripe you'll see on the cable here should go towards your power and SD card. And on the other side of the cable, the cobbler is slotted so you can only plug it in the correct way. Just put the white stripe towards the Pi Cobbler label. Now let's take a look at how the cobbler is laid out. As I said before, the cobbler just extends your GPIO pins out away from your Pi so that you can work with them a little more easily. On the cobbler, there are 2 leads that we're concerned with right now. This one here is marked GND, which is short for ground. And this one on the other side marked number 4. We're also going to later use number 17 and number 22, but for now, let's just concentrate on number 4. The first wire we're going to need to hook up is the ground wire. So let's find a short piece to run from our pin marked G and D and run it over to our blue/negative breadboard column. All right, easy enough. Now let's make sure the wire is aligned correctly with the G and D pin. Since we don't want to interfere with the rows where the other pins are connected, we're going to plug our LEDs and resistors down below the cobbler and make our connections there using some wires. So let's use row 18 here, and I'm just picking any of the rows below the cobbler. I just happened to pick 18. You could choose other ones, but for the purposes of following along with this video, use row 18. So take your red LED, hold it up, and you'll notice that there is a short leg and a long leg. The short leg is the negative lead, and the long leg is the positive. So let's take our short leg and plug it into the blue negative column at row 18. And then the positive leg can come across here to column A. Next, we need a resistor for our LED. So hold up your resistor and you'll notice it has 4 bands on it. The end with the 3 smaller bands are going to connect to our positive LED leg. So let's plug it in the hole here just next to the LED in row 18. And now take the other end and put it somewhere further down in, let's say, row 26. You could put it straight across on the same row, but I'm going further down just to give myself a little bit more room to work with the resistors. Now we need to get the end of our resistor wired up with the GPIO pin that we're going to use to control our LED. So let's get another longer piece of wire and plug it in here into row 26 next to the resistor leg. And then we'll go back up to the other side of our cobbler and find pin number 4. Looks like it's on row 6, and now we should have a complete circuit. Now that we have our wiring all set, let's move on to the software side of our project. And you should already have Raspbian installed. If you don't, check out my Berry Boot tutorial. So go ahead and start up your Pi and log in. And we're going to be using the Python language to control our LEDs. So if you don't know Python or any programming at all, don't worry. We're going to be using a very small set of commands that should be fairly easy to follow. And there are a few things that we'll need to install before we can use Python to control the GPIO. We're going to use apt-get to install Python dev and Python pip. Then using pip, we'll install rpi.gpio. So let's do that now. So you're going to want to type sudo apt-get install python-dev. And once that is completed, you're going to want to type sudo space apt-get space install space python-pip. And then once that has completed, type sudo space pip space install space rpi.gpio. And the rpi.gpio is case sensitive, so make sure you type that exactly as you see it on the screen with a capital R, a capital P, a lowercase I, dot GPIO, all in capital letters. Now, once you have all of the Python packages installed, we can move on to writing a Python script that will control our LED through the GPIO interface. And remember how we wired our LED to use GPIO number 4? Well, let's start setting that up in software to control our LED. First, we're going to need to get permission to access the hardware with Python, and we need to be running with root permissions, so let's do that with sudo -i, which gives us super user or root permissions in interactive mode, so we don't have to type sudo every single time we need permission. Now we can run the Python interpreter, so type Python and hit enter. Now you'll see a different looking command prompt, and here we need to tell Python that we want to use the GPIO library. So import rpi.gpio as GPIO. And type this just as you see it on the screen. I'm not going to continue to remind everyone to use the lowercase and uppercase. Just copy it exactly as you see it on screen. And we also want to access the Broadcom chip. So we do that by typing this gpio.setMode open parentheses gpio.bcm close parentheses. Now we have to set up our number 4 pin. So gpio.setup open parentheses 4 comma gpio.out close parentheses. And now we're ready to light this little guy up. So I hope you're ready. Here goes. Now type GPIO dot output, open parentheses 4, comma, true, close parentheses. And drum roll, please. Hit enter. And okay, if you did everything correctly and everything is wired up correctly, you should now see your LED lit up. If not, check your wiring, make sure you didn't miss something. To turn it off, it's just as easy. You type GPIO dot output, open parentheses 4, comma, false, close parentheses. And you can also substitute 1 for true and 0 for false. So you could also have typed GPIO dot output, open parentheses 4, comma, 1, close parentheses to turn it on. And to turn it off, GPIO dot output, parentheses 4, comma, 0, close parentheses. So that wasn't that hard. Pretty easy, right? I know it took a while to get there, but now that we have the red LED set up, or whatever color you purchased, let's move on to the yellow and green so that we can make our stoplight. If you only had one LED, you're pretty much done with this part of the tutorial. And if you have more than one you want to set up, you can continue on to part 2. And even if you don't, you may also want to continue and watch part 2 for some more advanced program scripting that I'm going to cover, like making the LED blink and so forth. So anyway, that's the end of part 1, and we'll pick back up on part 2.